In today's video, I have an NAD model 7155. The owner of this unit is claiming that it is not memorizing the radio stations. So we're going to take a look at this unit and see what's causing the problem. It could be a bad battery, or in many of these they use a Supercap. So let's check it out and see what's wrong with it. So first we'll power the unit and notice that it's on 87.5. I'll hit the scan button, and as you notice, it's not stopping on any radio stations. It's just continuing to scan. But it should remember the last state. So if I power it off and power it back on, as you can see, it's gone back to 87.5. So on this NAD 7155, the complaint on this is that it loses the frequency stored in memory. So we'll open it up and see whether there's a Supercap in it that's gone bad, or if a battery needs to be replaced. Okay, right here on the board, this is going to be a Supercap that's used to store the station memory. And what can happen on these is, well, a couple things. One, the solder connections below it can break, and then the unit's not getting a charge. And two, the capacitors can just fail after a period of time. So let's first of all check it out and see whether it's storing any voltage. We first need to remove the control/tuner board, which is done by removing the 6 screws around the perimeter, and that way we can lift the board out and check the connections and check the condition of the Supercap. Optionally, you can remove the LED indicators from the panel, which are in the way. The wires are too short, or you could just unplug the LEDs from the connectors. Keep in mind, if you unplug it, that the leads themselves can get bent, and if you bend those LEDs too many times, the leads actually will break. So I chose, in this case, just to remove the circuit board. That way I'm not putting any undue stress on the actual components themselves. As you'll see, these are not the easier, or one of the easier units to work on, because there are a couple boards on here, and a lot of the amplifier electronics. This is the tuner. This board here has got all your low voltage and your tuning circuits on it. The main amp and the regulators are down here on the main board, and here's the relay here for the I believe that's the speaker relay. Input switches are at the back here, so they have these long shafts. They go all the way to the back, right through the heatsink, basically, to get to the switches on the back. Okay, well that should be up enough so that I should be able to measure the voltage now on this thing, see whether it's holding a charge. And at the same time, if I apply power to the unit, the frequency will probably show 87.5 or whatever it went back to as a default. If I apply power, yeah, see, it hasn't stored anything, and that's because the Supercap here is not holding a charge. This is it here. Let's just see if there's any power on it now. Nothing. See, it's going down real quick. It'd help if I connect it the right way here, but if I turn the unit on, this unit will charge up to 5 volts. If I turn it off, the voltage is going to drop off right away. So what I need to do is I need to replace the supercapacitor on this unit so that it will once again store the frequencies for the radio stations. If we look down into the regulator circuit here, this capacitor here looks to be an ideal candidate for replacement. It's not bulging or anything, but it's obviously gotten warm because the plastic wrap is starting to shrink around it. So this is one that's been hot. And these ones here are actually have the potential to become little bombs. As you see, there's no stress relief for venting on these old style caps. So what would eventually happen if there was a failure, pressure would build up so high inside that these things would actually go off like a bullet, and the can would fly through the unit, and you'd have pieces of paper and foil just blown to pieces inside. These were actually kind of cool. We used to play around with these things when I was in high school. You know, we would intentionally put them on a power supply and crank up the voltage, and you know, it'd only take a few seconds, and then there'd be a loud bang, and it was like a bomb going off and scare the hell out of everybody. Like, well, firecracker anyway, going off and scare the hell out of everybody. And in the meantime, there was confetti everywhere. And then they came out with a new design like this. As you can see, newer capacitor design, they've got this stamped stress relief so that if the pressure goes too high, this will actually pop and it'll open up, and then the capacitor will vent, and it will vent safely, and you'll have a lot of smoke and stink, and you know, and the cap will fail, but it won't fail to the point where the can actually explodes like these old ones did. So I think probably a couple of these ones should be replaced. That one definitely needs to be replaced in here, just because we can tell that, you know, it used to look like that, right? And it's gotten warm, and the actual jacket of it is shrunk down. So that one's going to get replaced as well when I change the battery on this. I'm just waiting for the iron to warm up a bit here. We'll take that Supercap out and take a look at the value of it. There it is. Let's get a close-up of this and see what the value of it is. Looks to be 0.04 farads at 5.5 volts. It's very difficult to see. I was using my magnifier, but the printing here is, you can maybe barely read it there. Looks like it was a Mashusta capacitor, Supercap, and you might be able to read it there, but I'm going to check around and see if I can find one of these things, and if I can find one, we'll go and pick one up and replace it. So you'll notice that the Supercap has a 3.4 volt charge on it right out of the package. It's because it's storing up. We'll just discharge it here, put a screwdriver across it, and we'll measure it again. And what we'll find is that it's actually going to start to recover. And this is how capacitors are. This is why large caps, you always make sure that you discharge them and leave your short in place, because they can recover a charge just sitting open. Now, as you can see, this one here, the new one, it's holding a charge, but if I go back to the old one that I'm replacing, this one is dead completely. So let's get the new Supercap mounted on the board here. Now, when we're replacing the Supercap, polarity is obviously very important. We have a negative lead here, identified by the minus terminal. And it's also the one that's connected to the case. The positive terminal is the one with the insulator. As we can see, the terminal, the dot over here, indicates that the Supercap goes in that direction. This is a little bit physically larger than the original one, but it fits. The pin spacing is the same, so just pop that in there and solder it down. And now, before I power this unit up, I'm going to remove the bottom so that I can change out this other cap down here that I'm concerned about, because it's obviously has been overheated. So let's just tip the unit up on the side so that I can remove the bottom. And it looks like this screw is kind of stripped too, because it's not unscrewing, so I have to give it a bit of help there. And it actually came right out of the bottom. Huh. looks like they cross-threaded the screw in the chassis, and it actually came right out of the heatsink. That's good. Let's see if we can get that screw out so that I can rethread the heatsink post, because that was actually holding down a thermal cutout on the board. I can't wait to get rid of this big scope and get something newer, because this monster that's on my bench takes up half the room where I normally keep my tools. Okay, we'll just rethread. Okay, now to remove this capacitor here, you can see here it's been hot. So that cap, I'm gonna stand the unit on its side here, and we'll just do the classic heat and rock. Pull the cap out like that. There's the one that's coming out of there. Negative is on the down side here, right? So positive is facing towards me. It is marked on the board too. This one is 220 at 35 volts, and there's nothing special. It's not a high temperature or anything, but you can certainly see, if I get a close-up of that capacitor here, if I can get the camera to focus, you can certainly see that this one has certainly been getting warm, because it's causing the actual plastic jacket has been shrinking around it. So let me find a new one, 220 at 35 volts. We'll get that one replaced. In case you guys are curious as to whether the ESR is going bad on this, a 220 at 35 volt capacitor should be no worse than 0.17 ohms. This one here, 0.71. So it's bad. I have a new one here, and well, it's not a new one, but it should be better, and it's 0.15. So I just measured the voltage. This is in the negative supply, and that capacitor is charging up to 36 volts, and it's a 35 volt rated cap. So what I'm going to do is I'm going to replace it with a couple. I don't have quite the size that I need, but I'm going to put a couple 100 microfarad at 50 volts in. That way we have plenty of headroom, because they're running that really close to its limit, and that's probably why the thing failed like it did anyway, because they're charging up a 35 volt capacitor to 36 volts. That's a recipe for disaster. So I'm just going to tack one in the board, and I'll put the other one on the bottom of the board. That way we'll get fairly close in our capacity. We'll be pushing 200 microfarads instead of 220, but I think we'll probably be fine with that, because most caps, well, if we measure them, they're going to be higher. Okay, that should work perfect. I'm just going to put a bit of insulating tape underneath it just to make sure that nothing ever touches. So we mount the board. First you have to make sure you get the LEDs in place, because if you don't put the two LEDs in place for the FM stereo and soft clipping, you won't be able to mount them later, because the screw hole is covered up by the board here. Okay, now we can slide the board back in place. Make sure that you're on top of the chassis here, not hooked below it. And the board will drop in place and line up with the 6 mounting holes. And of course, right here I see one that looks questionable, and another one over here. This is the cap that I took. I just took my strip of tape off there so I could look underneath it, but this is the one that we just changed. And as you notice, the positive side is actually going to the ground because this is negative, a negative filter. So I'm just going to go over a few of those connections on some of these regulators here and reflow them. So something you may have noticed about this particular NAD that I'm working on now is that this one was made in Japan. Whereas the last one that I was working on, same guy that owns the both of them, right? He's got a number of these things. The last one he brought me was made in Singapore. And I didn't find nearly as many connections that I would consider to be suspect on this one as the other one. The other one was loaded with them, and that's why it was cutting in and out like it was. Okay, the unit is now connected. Let's check it out and see if it works. We appear to have a problem because it's tuning. I don't hear the speaker relay kicking in, and I don't hear any sound. It's holding the memory now for the radio station, which it wasn't before, and it's tuned. I hear no sound. We'll have to investigate further and see why we have no sound on this thing. Okay, I've got the scope hooked up so we can see where the problem is. If you notice, if I turn up the volume here, we've got audio. I've just got the scope hooked up to the pre-out main in. So we have a problem on the amplifier section on this thing. Because as you can see, we've got signal making it through to the 1963 scope, which I'm surprised that this thing still works, considering that it's as old as I am. But we've got good signal getting through the old scope, so we had to figure out why we're not getting a signal through onto the power amp here, why the relay's not cutting in. It's like it's in speaker protection, but why? And I didn't test this thing. I broke rule number 1 when I get a piece of equipment in. I believed the customer where he said, "Oh, it works fine. It's just it just doesn't remember the stations," which it didn't remember the stations. But I didn't test it first, so I now need to figure out why it's not working. We know that the tuner, the radio is working because it's been off for a couple of hours and it's stored the station. So that part's fixed. Now we've got to figure out why we're not getting any sound through the outputs here. If I clip on, you can see that we do have an output. This is the output transistor. So we do have signal going through the outputs. So we know the outputs are working, it's just that the relay is not energizing. I think this is the relay right down here. So let's just take a listen and see whether I've got sound here. I got sound there, but I have nothing here. So what I've determined so far is that the amplifier is working, it's just that it is in protection mode. The relay is not becoming energized. So now I have to troubleshoot that circuit and find out why the relay is not energizing to turn the sound on to the speakers. Sound there. There's sound there because you can see it. And I believe this is the relay right here. I'd have to. This is one side of the relay here. This is the other terminals, and these ones here. These ones are these two here are probably the coil. Anyway, put the meter across there and see if there's any voltage on the coil. Nothing. Okay, as I've been chasing electrons here, back onto the main board, and I've done some chasing of circuitry. I found that the 48 supply comes in here, goes through a resistor, into the coil, and it comes back through the coil, and then at this point here, it jumps over on a wire which brings it over to this point here where it goes through this thermal cutout, which is a switch that if it gets too hot it'll cut out and shut off the speakers, comes back to here, which ends up coming back on another jumper wire which ends up right here, which goes into this IC. So this IC here is the speaker protection IC. And if we look at the voltages here, if I turn on the power, and we look at the voltages here, I've got 46 volts. Now this would normally ground out to turn the relay on. And that's fed from this IC here. There's our 8 volts. As I continue to check the speaker protection IC, it's apparent that there's no voltage other than the output that's going to the coil of the relay. I have a feeling that this IC is not getting power. That would explain a lot. This IC is not getting power, therefore it can't operate the relay if the IC itself hasn't got power. It's got the control output, but the circuitry here doesn't appear to be getting power. So there must be a connection here somewhere that's open, because I would expect to have a 12 volt line or something powering up. Okay, there's 3 volts there. So there's 3 volts on that pin, and nothing, or what, 0.1? 0.1, this will have the 48 volts. See, 0.6. I would expect that one of these bloody pins is going to have power. It doesn't. Either that or its IC's cooked. I'm just looking to see which way it's fed. .48 volts, 0 volts, 48 volts. Now, of course, at this point, it would be great to have a schematic diagram so I could actually trace a circuit. So I'm just looking at the traces, trying to determine which direction feeds this and where it's fed from. 24 volts and 0.6. That might be a resistor there. Let's just take a look and see. I'm sure I'm going to find that we've got something, a resistor or something that is open here. It appears to be a resistor right here, but I've lost my voltage across it. So I'm just going to pull it and measure it. Color code is yellow, violet, orange, 47K, 47000, 47K. So what do we got here? Okay, it's not open. Interesting. Okay, well that's where I'm losing my voltage drop. So something is draining that down. I'm just going to stick this resistor in the bottom here. I'm just sticking the resistor in the bottom just because where it's located, there's a metal bar right over top of it, which makes getting at it difficult. So I'm just going to tack it in the bottom of the board, which will be just fine. So we're having a big voltage drop across this resistor because we've got 24 volts on one side of it, but we've got like 0.6 on the other. Huh. 0 and minus 25. That's a voltage regulator. Well, I think it's time to actually go and find a schematic for this thing so that we can actually troubleshoot the circuit properly. I'll do that tomorrow. I've gone and dug out a schematic for this unit, and what we'll do is we'll go over the schematic diagram and we'll find the circuitry that we're interested in for the speaker protection circuit, because for some reason it's not kicking in. I'm just going to go find myself something to write with. Here, I got a pen here. And we'll look down at the circuitry here and just chase through the circuits and chase electrons, basically. Because when I was working on the unit, I found that I'm not getting voltage to the speaker protection circuit, which is this area right in here. Okay, here's our speaker protection. Here's our relay coil right here. This is the coil here, and I've actually got a blow up of this to make it easier to see. So here's the same circuit that I've blown up. Here's our relay coil right here. There's the diode across it. We had our 48 volts coming in right here, passing through this resistor. This is that thermal cutout switch over here. If we look on the full size schematic, here's the same circuit here. Here's that thermal cutout switch that is mounted to the heatsink. So we know that this part's working. The 48 volts goes out to the thermal cutout switch. This is the thermal cutout switch here, right? Comes back in here. We had 48 volts on pin 6 of, I think it was pin 6. It came in here 1, 2, 3, 4. What is it? I'm just going to count them over here. 1, 2, 3, 4, 5. Yeah, pin 6. And it's a 9-pin IC. It looks to be that the 48 volt supply comes in. This is our 48 volts here. Because we know it's feeding R807, which is feeding the relay. So we know that the power is there, but you see it also goes through this 18K resistor right here, and it should show up at pin number 9. So let's check to see whether I'm getting any voltage through this 18K resistor. And then there's another 220K resistor which feeds to pin number 8, and then there's a little capacitor here, a 10 volt 22 microfarad capacitor on here. Now I wouldn't expect the cap to be shorted and drawing the power down, because we would still expect to see some voltage on pin number 9. 8 would become low, but 9 would still have some power to it. And I'm just looking here, the other source here, This is going to be a plus source. I think pin number 5 is probably going to be a negative source. So let's just follow this one here. It also goes through an 18K resistor. This one probably goes to the negative supply. So let's follow this one back and see where the heck this one goes. Yes, this one goes to the negative 46 supply. So our negative 46 supply is over here. That feeds down this one and goes through this resistor. So this 18K resistor, this should be the negative 46. And this is the 46 or 48 supply. But anyway, negative supply, positive supply. This is an op amp. Here's our inputs here from our speakers. Right down here, these are our samples for our speaker circuit. So we're checking for DC voltage. If there's any DC offset, this thing's not going to work. That's how this is designed. As long as we don't have a DC voltage here, this is a comparator. And unfortunately, the schematic isn't that good. There's a diode and stuff in here that didn't get printed. So there are some portions of this schematic that didn't print. But basically how this works is if there's any DC voltage present, it won't allow the output, and it will kill the relay. So, but we need to have our positive and negative supply voltage, and now we know that pin 9 and pin 8, or sorry, pin 9 and pin 5? Let's say pin 5. Yeah, pin 5. So pin 9 is a plus voltage, and pin 5 is a negative supply. So now we can measure the voltage on the amplifier and see where we're missing a voltage, why it's not working. Okay, I'll try to bring the meter in this frame here so you guys can see what we're looking at here. Okay, so we'll look at pin 9 first. And see whether we've got our supply, just making sure that nothing's touching over here. Okay, put on power. It's got power. Okay, we'll look at pin number 9, which is going to be this one right here. And we'll see whether we have 3 volts here, which is low. And how about pin 5? 1, 2, 3, 4. Pin number 5 is this one here, and it is 0.6. We go back up to the other side of this resistor, minus 3, minus 3, minus 3. We'll just check some of these other ones here. The way that this one goes back. 3 volts. Okay, 48 volts there. 3 volts here. Sounds like that IC is no good. Something's loading that down, and pin number 5 is, okay, 48 volts. Well, that's pin 6. Pin number 5 is here. 0.6 minus 3. Minus 3. Just following this back to see where it goes. This goes up to here. Minus 3. Minus 3. We're in the negative supply here. Minus 3. Minus 4. Minus 62. Aha! So this regulator is down. That's fed off of here. Minus 4. Minus 27. 0. Minus 4. So you're going to check out this regulator up here. I'm curious as to whether this transistor here is shorted. Let me just check it and see. In circuit. Oh. You know, that doesn't... I think I got an emitter to a collector short. Q803, let's just check this one out of the circuit. So, okay, we got a good base to collector junction. We have a good base to emitter junction. we have emitter to collector short. Well, let's see if I can find another one of those. This is a 2SA 1015. Let's see what that subs out to. So here's the transistor on the schematic. I've got a little dot beside it here. This is the one that's bad, and it drives the one next to it here. I gotta use my magnifiers to read that fine print on the paper because it's so small. It's Q903, and it drives Q902, which is this one here. And Q902 is the minus 46 volt regulator. So let's look this one up and find a replacement. I'm sure I probably got one that I can. I'm sure I've got a transistor around here that'll fix this. This is just a general purpose. Let's look it up and see what it crosses to. So we'll get out the old BlackBerry here and run NTE quick cross. It's 2SA 1015. That crosses to an NTE 290. See if I can find something that crosses to an NTE 290. So we're going to do a little transistor substitution on this unit here. People ask me sometimes, my friends and family and stuff, say, why do I keep scrap boards? Why do I have boxes full of scrap boards? Well, because I keep scrap boards because there are valuable parts on a scrap board, especially when you get an older component that the parts are becoming obsolete. Now on this board, I see that I have, camera's not going to focus properly on here, I have a 2N3906. You can see it sitting right there. A 3906 crosses to an ECG or NTE 159. If we look up the specs on the 1015, we'll see that it crosses to an NTE 290. An NTE 290, if we look at the specs, is rated at 80 volts. Actually, collector to emitter 100 volts, but we're nowhere near that. We're working at 48 volts. We have a collector to emitter voltage 80, emitter to base voltage of 5. If I go and look up a 2N3906, that crosses to an NTE 159. And if we look at the specs for that, we see that 80, 80, and 5. Well, we got lots of headroom. So that NTE 159 equivalent, which is the one that I'm going to pull off this board here, which is this 3906. The basing may be different, but that's okay. That don't matter. I can certainly restructure the lead so that it is based correctly. We're going to pull this transistor off the board. Check our basing. We know it's a PNP, so let's just see what our basing is on this one. This is probably going to be emitter base collector instead of base collector emitter. So I'll put my negative probe on the middle pin, which is going to be the base. And we have, there we go, one and the other. And no short between the emitter and collector. The other one was base collector emitter, the original one. The original one we know because we did not have a short. We only had a short emitter to collector. Okay, there's our base. Base to, this one was base collector emitter. So base to collector was good. Base to emitter. And emitter to. So this one's base collector emitter, and this one's emitter base collector. So we just have to rearrange the leads accordingly so that we get the right basing, otherwise it's not going to work. That's the art of substituting. A lot of times you can substitute transistors, but you have to remember that the pin configuration is not always the same. So you have to know what your pin configure, or what your basing as it's called, is when you put the original one in, because this one here won't be fitting in the same way. I'll have to turn it so that I get my base in the correct, and the emitter and the collector in the correct orientation. I don't know if you guys can see it or not, but this one's actually marked emitter base collector. This one's not, but this one's marked EBC. I already knew that, but I'm just pointing out that sometimes they mark it on the component itself. I should also point out that the base is, it's actually emitter collector base. I don't know if I said that before or not, but the basing on its emitter collector base. I do that also by looking at the schematic. The base actually has a B mounted on it, but it goes to resistor, what did I say it went to? It went to resistor R916, which is, yeah, which is that one there, right next to it. So it's emitter collector base, and my transistor was emitter base collector, so I just bent the pins accordingly so that it's in the board in the correct basing. And then we'll put this transistor back in. And of course, make sure that there's no shorts. Good. Here's one junction, and there's the other. Okay, now, with any luck, when I power this thing up, I will have voltage, and I will get sound. Done it! Yes, that's how you troubleshoot. I'll turn this thing on before something touches. That is how you troubleshoot an amplifier with a blown transistor. Just start measuring things out. You really do need a schematic to do it. As I say, I spent a little bit of time when I was working on this before getting the schematic for it. I did spend some time troubleshooting, so I knew I had it narrowed down. But without that schematic, I would have been, chasing electrons, trying to figure things out, because here's where my trouble. I knew I was in distress down here because the relay wasn't energizing, but here we go, it's up here where the short was. So anyway, hey, that works. Let's get this thing put back together and test it out. Incidentally, I had taken out the board before for the LEDs, but you don't need to do that. You can actually just unplug them, although they will get kind of bent if you're not careful. These plugs just come out. Just have to remember which one goes where, but that's not tough. It saves time of undoing that little board. You just have to be careful not to break the leads off the LEDs. You've got the two connectors that connect up to it. Get the board back in place. And I haven't bridged the second cap in just yet. I'll do that in a minute. I put in a, it was a 220, and I put in a couple 100 mic caps in place of it. The one that was bulged out. I haven't put the other one back into the bottom yet. I'll be doing that momentarily. They're just filters anyway, so I don't think they're that critical, but okay, we have two lights on the front here. One is marked FM stereo, one is marked soft clipping. The FM stereo is this one here that comes off the board. The soft clipping comes from below. The positive lead is on the right, so just take your leads from the LEDs that are sticking out, providing you haven't snapped them off, and straighten them out and insert the plug. Like that, and the same for the other one. There you go. The LEDs just basically sit in there like that. Now we can test this thing again. It's ready to go. Make sure there's nothing touching on the bottom. Power it up. It held the frequency overnight with no power. There we go. So we replaced the super cap on this thing, but in the process, I don't know how or why that transistor failed. Nothing was touched or anything. So it was a transistor that was bad. I don't know if it was bad before it came in here or whether it failed once it was in the shop. Regardless, I had to change it. I had to troubleshoot it and find it. We replaced it. It was a cause of a loss of negative 48 volt supply that drives and biases the amplifier. So that solved that problem. I'll go in and put that other capacitor back in here, just bridge that second cap, and then we'll put this thing back together. Okay, got the cap mounted back on the bottom here of the board. Power it up. There we go. Unit's working fine. We can get the cover on it now and send it back on its way. I don't want to play that for more than a few seconds there, as I don't really need to get a notice from YouTube that I've violated anybody's rights. I tend to pick up enough of those, even when I use royalty-free content. I get some goof that makes a claim that it belongs to them and have to dispute it, and hey, I win every time, but it's just the hassle of having to go through the motions and find my paperwork for my find my paperwork for the music I've used and get it sent off, and then I have to wait 30 days. So while that whole dispute is ongoing, I don't make any money on my videos. So anyway, hope you guys enjoyed the service of this NAD 7110 or 7155. Let me get the top on it. We'll do one final test and then send it on its way. Put a nice little wire tie around here. Nice little yellow one. Make it nice and neat. Zip tie all the wires together. There. Good as new. Thanks for watching, and we'll catch you in the next one real soon.